Dr. D. Uttara, Associate Professor of Physics, heads the Department of Physics at D.G. Vaishnava College, Chennai, and has more than 20 years' experience in teaching physics. She did her doctoral research in the field of vibrational spectroscopy at the University of Madras, Chennai. She completed her UG in Physics at Ethiraj College for Women and PG in Physics at Pachepa College, Chennai. She effectively used technology and social media for dissemination of knowledge through her own websites. She has delivered several science talks in All India Radio, Doordarshan Kendra. She has been actively involved in dubbing science videos and translating science books in Tamil. She was a project fellow for the UGC major project, Februarization of Computerized Microwave Bench for the Dielectric Studies, and later she was awarded Teacher Fellowship by UGC for completing a PhD program. She is playing a key role in evolving a curriculum of physics at undergraduate level as a member of IQAC Board of Studies member and Board of Examination in various city colleges.
Welcome students. Welcome to the UGC lecture series on Electronics Practical 5. Today let us see how we can construct a 4x1 multiplexer using logic gates. What is a multiplexer, or we call it as MUX? What is it? Imagine a situation, you have a single data line, but you have more than one data coming to it. You want to pick only one data and you want that to flow out. So, you want to select, is it not? So, how can you do that? Here comes MUX. So, multiplexer or MUX is an electronic circuit that has n inputs and one output. A multiplexer is a data selector that has 2 power n input lines and it has only one output line. Any of the inputs can be brought out as the output. Let us design a 2x1 MUX based on your knowledge on Boolean algebra. Here we go. How can we arrive at the logic behind MUX? If we have the inputs, the number of inputs greater than 1 and we want only one of them to flow, how shall we do that? You are right, this is nobody but Boole. Yeah, using Boolean algebra. How can you get it? What do you want? This or that. So, you have two inputs. Out of the two inputs, you want to select only one of the two. So, how shall I represent it? I represent it using this block diagram. What does it mean? It has a significance. What is it all about? You have a rectangle and it says 2x1 MUX. What does it mean? There are two input lines and we call it as I0 and I1, two input lines, and you have one output line. So, one of the input is going to flow through the output without any change. Remember, either I0 is going to flow or I1 is going to flow. How are we going to decide which is going to flow? Yes, here comes your selection line S0. For a 2 input MUX, you have 2x1 MUX, you have how many selection line? One selection line. Fine. So, shall we try to design a 2x1 MUX? We call it 2x1 multiplexer. What is the output? It is either I0 or I1 as we saw just now. So, who is going to help you to select? The selection line. So, what are the values that a selection line can have? Obviously, it can be low or it can be high. So, when it is low, one of the input is made to pass through the output, that is I0 flows. If it is high, that is the selection is high, then you get the output I1. When S0 is 0, selection is 0, what do you want? I0. How will you achieve it? S0 bar I0 is equal to I0, while S0 I1 is equal to 0 when S0 is 0. We will come back here again. You want the output, one of them right now this is in 0 condition. Look this, you want I0 to flow through as output and what do you want to flow? I0, and what is your condition? S0 is 0. So, how can I achieve I0 to flow here? S0 bar now becomes 1 and it is combined with I naught, whatever may be I naught, we are not worried about it. S naught bar I naught allows I naught to flow. Can you now guess what gate we can use or what logic we can use? Keep guessing. In between I naught flows through the gate and goes out. What about I 1? S naught is 0. So, what will happen? S naught I 1 is not going to flow and it is 0. I hope by now you would have guessed what gate you would use. Now, you are getting I naught. When S naught is 1 or the selection line is in high state, what you want to flow? I 1. What should happen to I naught? It should not flow, rather it should become 0. Let us see. So, S naught I 1 is equal to I 1. Let us see what happens. So, output is I 1. You got it. By combining S naught bar and I naught and using AND gate, you can achieve it. Similarly, combine it using AND gate. How will you combine both the outputs? Let us see. Can you design the circuit? I hope you would have guessed it right. You can arrive at the same expression using min terms. You got 2 line to 1 line data selector. Let us see what is going to come here. Yes, as you thought, you are going to use an OR gate to combine S naught bar I naught and S naught I 1. You are going to combine them using OR gate. So, what should be the final circuit? You have I naught, you have I 1 and you have a selection line S naught bar I naught, S naught I 1. How do you get it? Using AND gates, and finally, they are given to the OR gate and you get the output, final output. Fine. So, this is all about your 2 by 1 mux. Students, here you are looking at the circuit of a 2 input multiplexer. There are 2 different inputs and there is one selection line. Based on the condition of the selection line, the output will be equal to one of the inputs. So, multiplexer just transfers the input to the output. There are more inputs. The output becomes equivalent to the input based on whatever you choose. So, it gives you a choice. How do you choose? Using the selection line. So, in this case, we are going to use 3 different ICs, OR gate, an AND gate, an AND IC, rather 2 AND gates will be used and 1 NOT gate. This combination in this way gives you 2:1 mux. In this 2:1 multiplexer, we have chosen I naught to be 0 and I 1 is kept at 1. This is just a choice. You can make it different also. So, right now I naught has been given low and I 1 has been given high. I have the selection line. Now, what have we done? When you give 0 to the selection line, it chooses the output to be what? Once again, you can check it yourself. Look at the voltmeter, S naught, the selection line I have, I am making it as low. So, what is the output? It is low. What is it? It is nothing but I naught. So, when the selection line is low, output is nothing but I naught, the input itself. Which input? I naught input. Now, let us go to the next choice. The selection line is 1. Shall we give? Selection line is 1. What is the output? The output is nothing but the I 1 input. So, out of the 2 inputs, it has chosen the second input when when S naught is 1 and the first input when S naught is 0. When selection line is 0, you can see the voltmeter reading chooses I naught, the first input. When selection line is high or equal to 1, the voltmeter or the output chooses the second input. So, mux or multiplex just transfers the input to the output side by giving you a choice by using selection line. Now, how can you design a 4 by 1 marks? For 4 inputs and 1 output. What are the 4 inputs? I0, I1, I2 and I3. These are the 4 inputs. In case of 2 by 1 marks, you have to select 1 out of the 2. In this case, only 1 of the 4. So, you need 4 different combinations of selection lines. What are they? 0, 0, 0, 1, 1, 0, 1, 1. So, can you guess how many selection lines you need? You need 2 selection lines. S0 and S1 are the 2 selection lines that we are going to have. So, how are we going to do that? Again, you can take a guess. Some students are very good thinking of the entire logic and arriving at the Boolean expression just by thought process. While some people need pen and paper, in that case, please use your Karna map, please use your min terms, however you want, you can arrive at the Boolean expression in order to design a 4 by 1 marks. So, whatever you do, whatever process you want, pen and paper or just mental logic, you have to arrive at the same logic, is it not? Once you think in the lines of the 2 by 1 marks, you can arrive at the 4 by 1 marks also. I am going to give you some more time. What is the logic that you must have arrived at? Let us see. Yes, this is what you want. So, you have a function table. So, I naught, when both are 0, you arrive at I naught, 0, 1, I1, output should be I2 when it is 1 and 0, and I3 should be the output when both S1 and S0 are high. Once you do this, this should be your Boolean expression. Shall we go back and check it? See here, 0, 0, I naught, 0, 1, I want I1, 0, 0. So, what happens? 0, S0 bar, S1 bar gives you what? High, the output to be I naught. Shall we go back? 0, 0, I naught. For this, how can you write your min term? Yes, S1 bar, S naught, S1 bar, S naught, I1. Then for this, for each and every output, I think you can arrive at this. And finally, as in earlier case, you are going to use AND gates as well as the OR gates to combine them. Let us see. Y is equal to S1 bar, S0 bar, I0, is it not? Plus S1 bar, S0, I1 plus S1, S0 bar, I2 plus S1, S0, I3. Is this not that we arrived earlier? So, what shall I do with this? Finally, I need a OR gate to combine all of this. Yes, this is my output. Why? Now, what do I need? I have 4 different 1, 2, 3 inputs. 1, 2, 3, 4. What should I have here? S1 bar, S0 bar, I0, S1 bar, S0, I1 and so on. So, how will I achieve this? By using AND gates at each and every point. What do I need? It should be S1 bar, S0 bar and I0. Look here, whatever is here, I am going to get this or derive this using AND gate. Now, here what do I have? It is nothing but a NOT gate. So, how will I achieve that? So, S1. Here we have S0 bar, is it not? S0 and here I0. So, similarly for all these also you can work upon AND gate, NOT gate and then OR gate. Using a basic logic gate we can achieve this. But in normal usual regular lab classes, do we have this 3 input AND gates? No, you may not have the required chip. Yes. So, what should I do? Do I have 4 input OR gates? No. So, what can I do that? 4 input OR gates. So, should I just omit it? Not necessarily. Here, in order to arrive at this, why can't I use few more AND gates or OR gates, or how can I differently combine all these things? This is the logic that I want. If I do not have 4 input OR gate, that should not stop me from doing this. Students, I think by now you must have guessed how to design a 4 by 1 multiplexer. You know, in that case, you need 2 selection lines and you will have 4 inputs, out of which one can be allowed to go to the output side. So, what would you need? Here it is. You can look at the circuit. You need few AND gates, NOT gates, and then the outputs are combined using OR gate, which we have already seen in case of the design of 2 by 1 mux. Here you can see 7404, the NOT gate, and 7408 AND gate. Similarly, I have one more setup. The output of these gates will be combined using the OR gate, which we will be bringing now. Dear students, always remember, whenever you are using more than one chip, you must be alert to give the supplies for all the chips as well as they all must be grounded. Remember this, if you are not going to give supply for at least one chip, your circuit will not work. Fine, let us see how we can combine. Let us have the OR gate away for some time. You have NOT gate 7404 and AND gate 7408 here. See, we have given the supplies. See here, we have interconnected the supplies as well as the ground is connected. Yes, similarly, once we bring our OR gate, the supply has to be connected as well as the ground. Remember and be cautious about this. Here is your circuit. So, what do we have? We need 4 inputs, out of which we are going to choose one. What are they? I0, I1, I2 and I3. You have the selection lines which are given using yellow color wires to the NOT gate. Depending on the combination of whether you give the selection lines 0 or 1, the entire multiplex circuit will operate and this will get connected to your OR gate. Let us remember, the output of the AND gates are combined using the OR gates. That is why I have the OR gate chip 7432, and right now we have not given any inputs here. So, the output of these two, the combination NOT and AND, will be given to the OR gate. Let us see that now. To combine the outputs from the AND gates, the output from the AND gates pin number 6 and 11 are given as inputs to the OR gates to pin number 1 and 2. Look here, it is better you check every gate individually before you start interconnecting them. That is always better. So, you will be able to troubleshoot what has gone wrong if something goes wrong. Look here, the next inputs for the OR gate will be 4 and 5, which will be from pin number 3 of the OR gate, earlier OR gate itself. See here, you have pin number 3, from 3 it goes to pin number 4. The two OR gates are interconnected. Where is the other input coming from? It is from pin number 6 of the next AND gate. Shall we give that? Similarly, from the next AND gate, 6 and 11 outputs are given to the OR gate as in the earlier case. Look here, these are the inputs to the OR gate. If you look at it, they come from the output of the AND gate, and the output of this OR gate goes as input of the next OR gate, and you have here the input, the other input of this OR gate coming from the next AND gate, and this output is given back. Similarly, you will be drawing another input from here, and the final output of the OR gate Remember, it is drawn from pin number 8 of the OR gate and is given to the voltmeter. By using this circuit and giving different combinations of S1 and S0 and as well varying your I0, I1, I2 and I3, you can always find which output you get out of the multiplexer. Whichever output you want, you can choose the selection, you can use the selection line and choose which input you want to flow through the output. In case you are more comfortable, it is better you use just 2 NOT gates, one for getting S0 and the other, in case if you are very comfortable, you can use just one NOT gate and convert S0 into S0 bar, S1 into S1 bar, and then you can supply it as selection lines in this circuit. So, there are other methods, and now you can see that how you can combine basic logic gates, enjoy designing the circuits, troubleshooting and enjoying and understanding electronics. All the best. See you then.